Okay, so today's lesson will be on a tutorial where we'll be looking at the questions which we have covered in the additional lesson. So in the additional lesson, we actually covered thermodynamics, forces, and kinematics, dynamics, and so on. So if you have any questions, you can actually feel free to ask me at the end of today's lesson. But right now, let's just get ready and turn over to your secrets and crows and to the mind map. Turn over to the mind map of thermal. That was actually our first chapter. So I would like to check that if all of you have completely understand what you need to understand in thermal. All right. Maybe can I ask Joby, can I just do a short survey with you? Are you okay with thermal right now? Is there anything that you do not understand? There are three parts in thermal: heat transfer, and we got ideal equation of state, and we got the last one, that's the first one. Are you okay with all three concepts, Joby?
Yeah.
Yeah? Any issue? Good. All right. Okay. Now I want to look at the second concept. Can everyone turn over to the second concept in your mind map? In the second concept is on the ideal gas. Now, how do you define ideal gas? Maybe Joanne. Ideal gas is a gas that is ideal. And if I ask you, what is the characteristic of ideal gas? What will you say, Joanne? What is the characteristic of ideal gas?
The volume of the molecules is negligible compared to the container.
The volume of the molecule is very, very, very small compared to the cylinder. Oh, yeah, that's one assumption. I think you all learned that from secondary school, right? And how about the next one? Benjamin, how about you? Give me another thing that you know about ideal gas. What defines an ideal gas? Is Benjamin thinking or is he hanged? Benjamin, you're hanged, is it? I think he's hanged. All right, Leah? Can I ask you, give me one thing about ideal gas? One thing. Hey, don't be surprised. They can ask you 2 marks. State what do you understand from ideal gas? So 2 marks. So what is the thing?
The volume they occupy is negligible compared to the volume of the container.
That's what Joanne said, right? Just now. She's saying that the volume of the molecule is negligible compared to the volume of the cylinder. When did you get this wrong?
No, they move in constant random motion.
They move in constant random motion. Okay, that's another assumption of the ideal gas. How about you, Ran? How about you? Give me one thing that you know about ideal gas. Molecule move in random motion. Volume of the molecule is very small, negligible compared to the volume of the cylinder. Good. 2 of them give me 2 marks. How about you? One more. No idea. Just that it's ideal. All right. Okay, Evangeline, how about you?
Is it negligible forces of attraction between molecules?
Negligible in the forces of attraction. That is because of what? Why do we assume that the molecules in ideal gas experience almost zero in the molecular force of attraction? Why is that so? Can you tell me why? That's what I'm looking for. Both of them are correct, but that's what Evangeline is saying is what I'm looking for. Why? Why is it that IM force is negligible? It's because in the ideal gas, the molecules are very far apart, right? So they're very, very far apart. So they're so far apart that the intermolecular forces of attraction is almost close to zero. And that is actually similar to what we understand in gravitational force. That if you are very far apart, if R is infinite, then the G force, the attractive force will be almost zero. So eventually, one more thing. You mentioned that the IM force will be above zero because the molecules are very far apart in an ideal gas. So when the force are almost zero, what about the PE? Will the PE be high or low? The potential energy of the system, will it be high or will it be low? Why? High, it'll be very high, am I right? Isn't it what you learned in gravitation? That when the molecules are very, very far apart, the potential energy gets less and less negative, and it reaches a maximum of zero at infinity. Is that right? So that's what we learned about ideal gas. I think what Joanne and Leo were saying is correct. Yes, the volume is actually very small compared to the cylinder. You can mention that it's random motion. That's right. Some of you may want to tell me that it's elastic collision. with the water cylinder. Some of you will want to tell me that the time during the collision is negligible compared to the time between the collision with the wall. Am I right? So all these are legit assumption of the kinetic model. But what I really want you to know about ideal gas, not kinetic model. What you all are telling me just now is a kinetic model. Yes, I understand that. But what I want you to know is that ideal gas, what's so special? It's so special because we assume molecules are so far apart, and therefore there's almost zero ion force, and that means that the P is almost maximum. That is zero. Now, which no, for real gas to be assumed to be ideal gas, what are the conditions? 1 mark for you. 1 mark. What is the condition that must be satisfied for us to assume that a real gas behave as ideal gas? Let me test you.
Low pressure and high temperature.
Well, he knows it without me giving him any hint. Pressure must be low, am I right? So real gas at low pressure behave as ideal gas. Why? So our room pressure, our atmospheric pressure, 10⁵ is considered to be okay, quite low, all right? So low pressure means that the molecules are far apart. That's why low pressure, right? That's why when real gas at low pressure, they behave as ideal gas, and therefore they obey PV equal to nRT, or PV equal to big N KT. Okay, now during the additional lesson, we mentioned about how the temperature is dependent on the average Ke of the molecule. So what we are trying to link up is the microscopic property versus the macroscopic property. All right, so the molecule, that will be the Ke, and that affects temperature. And therefore, we know that average Ke is 3/2 kT. I'm not sure whether you need a reminder here. If the temperature is the same, it means that average K is the same. But it does not mean that the root mean square speed is the same. Because the mass of the molecule can be different. If you compare different type of gas, it can be different. Am I right? So that's one very common careless mistake. Second careless mistake is that if temperature is the same, of course, average K is the same. But does it mean that the total K is the same? No. Because average K is the same, but the number of molecules can be different in the different cylinder. So the total Ke, the internal energy, may not be the same. So my advice for you in the additional lesson is that when people say thermal equilibrium, when people say same temperature, you just say they got the same average Ke and you put a full stop after that. Do not further commit. All right. Now we go over to the other side, that will be on pressure. What affects the pressure? So the pressure of the gas depends on two things: the frequency of collision between the molecule and the cylinder. Number two, how fast the molecule are moving. Both of them affects the force during the collision. And therefore, we can see that the pressure is a function of density. Density, of course, affects the FOC. And it also is a function of the speed of the molecule. But I owe you an explanation. I have not derived and proved to you that pressure, why is it 1/3 rho V squared? Why can't it be 1/5? Why can't it be 1/4? Why must it be 1/3? Where does the 1/3 comes from? That's the first question that you ask. Why must it be square? Why can't it be proportional to the speed? That's all. Why must it be proportional to the square? I owe you that explanation. It's not easy at all. Do you remember the nightmare? That will be last year when you learned thermal. I'm sure your school spent at least 20 minutes in lecture to talk about the derivation of this thing. And if I'm not wrong, they also have this diagram in your lecture notes. Remember this one? About how the molecules are moving in random motion in the 3D space, and they collide with the wall, and that force during a collision divided by the area given the pressure. It seems very easy, right? Pressure equal to force over area, and that's it. We can prove that equation. It's easy, right? So, however, it's not as easy as it seems. Let me tell you why. So before I even start, I want to tell you why I think it's difficult. Number one, if the molecule hit the wall one time in 1 second, no problem, very easy. Because the force will be just equal to change of momentum over time, very easy. But the truth is that the same molecule, that one molecule, hit the wall many times in 1 second. They may hit the same wall 100 times in 1 second. So that's a multiplier factor, which I hope you understand later on. You have to multiply by the number of times you hit your head against the wall in the 1 second, you understand. That's the first thing I must tell you. Second thing, there is more than one molecule in a cylinder. So therefore, later on, I need to multiply by the number of molecules. So there are two multiplier effects. Do you see that? The first step is that the same molecule hit the wall many times in 1 second. So there's a multiplier factor. And then there's another multiplier factor because there are many molecules, 1,000 molecules in that cylinder. And therefore, I must multiply again by the number of molecules. That's not all. That's not all. I want to tell you my problem. Okay, let me share with you my problem. The problem is that when you want to find pressure is force over area, let me ask Leah, back to you. You know, pressure is force over area, which eventually we will have to use it. Now, this force over area, this force, right, should it be the force that is right angle to the cylinder, or should it be the force that is at an angle? What must the force be? What's the condition of the force? I write down here, pressure is force over area. What's the condition? The force and the area must be what?
Perpendicular.
Perpendicular. You realize that? But of course, perpendicular will be very easy. But however, you know that the molecule, not all of them move in and hit the wall at right angle because they're moving in random motion, as you mentioned just now. That's why I asked you. So they may be coming in and hit an angle, you see? So basically, right, if the molecule is going left, right, left, right, left, right, easy for me. Because you go left, right, then of course, the velocity will be the horizontal velocity that give you your force, and that will the one that give you your force over area. Easy, right? But the truth is that the molecule may move at an angle in a random motion. So yeah, I'm only interested in the horizontal velocity to find my force. You get what I mean? So you need the force that's right angle to the wall. So that's another problem. I show you that. All right, that's the criteria over here. And if you understand all my problem, we can start now. Okay, let's start now. First of all, maybe the space here, we draw the wall of the cylinder, and in pencil, we label the separation between the two walls as L. And we will draw, of course, molecule, and that's moving at the speed of a U. And you hit the one of the wall here. Let's look at one of the wall, all right? You hit. And as you all know from kinetic model, okay, that's what you all state just now, the assumption under kinetic model, which I can ask you, you say, oh, because we assume that all the conditions are elastic, and that's why when you hit the wall, you will bounce off, but your KE, your speed will still be the same. So that's what happened. What you really want is to find the force added on the molecule. So if I draw the free body diagram, and that's the force that you want. And you know by action and reaction, the force on the molecule will be the force on the cylinder. And that force is what we want. And then we divide by area, that's it, okay? Now, I understand there are many molecules in a cylinder, but Sherry just made the assumption that there's only one molecule. All right, so I'll put it down over here. I need your help. I will divide this into two columns. I'm going to show you what your school notes would have. All right, which is, I will put it on the left-hand side, your school notes. Later on, I will do a bit of explanation on the right-hand side. So I need to reserve some space for myself. So what your school notes will have would be like this. They will say, look, the force, this is the F that you want to find, right? The force will be F equal to change in momentum over time. So I put down here, force equal to mass change in V over time. So that's what your school notes will have. And that is Newton's second law. Legit. All right. By the way, you run again. This mass, right, is the mass of the gas or is it the mass of one single gaseous molecule? I cannot hear you. Are you okay? How about Evangeline? I cannot hear you run. Evangeline, this mass is the mass of one molecule or is it the mass of the gas? Mass of the gas means the total mass of all the molecule. What do you think? Evangeline?
One molecule.
One molecule. You know that in this chapter, I'm very particular about big M and small m, right? So big M, I reserve it for the mass of the gas. Do you remember this one? You want to write down or not? This one is big N but small m. Am I right? Where big N is the number of molecule. I'm very particular about this. And then when you talk about average KE, then the mass will be the small m. Am I right? You know, before I see you next time for the next additional lesson, right? Can you have some sticky pad ready? Because you know that my secret enclosed is just A5 size, right? And on and off, from time to time, you want to add on more notes to yourself, to remind yourself. So therefore, you always have sticky pad ready. And at the end of the, after we fill up the secret enclosed, right, you will see that that book, right, will have a lot of sticky pad. It should be like this. And it should be very colorful, okay? So, yeah, I thought about the importance about big N and small n, and even for pressure on this side, I also want you to take note over here. I'm coming back to my, I'm coming back to my equation here. It's the mass of the gas. Eventually, this delta V, in terms of the speed of the molecule, which is U, what would it be? Delta V. It becomes what?
2U.
2U. All right, Vishnu. Now your turn. The time, right? The time. Do you remember how to derive this? First of all, they normally want to express the time in terms of speed of the molecule. This time. Do you know how they do it in school? Vishnu?
Not sure.
Maybe I help you. I remind you what they do. All right. So basically, right, this speed, the speed of the molecule, will be equal to what distance divided by time. What's the distance? So let's say the time is the time between the two collision with the same wall. So that time, right, will be the time for the molecule to go to the left and then return back to the right. So that will be the time. So this speed equal to what over the time t? What's the distance traveled? 2L, right? So 2L. So what your school will do is actually they will replace the time, right, with 2L over U. Do you remember this, Vishnu, or you completely forgotten?
I remember.
Remember? So they replace the T with 2L over U. Then finally, right, they find the force, okay, due to the collision between the molecule and the wall. So it will be, what do they get now? Okay, tell me, Vishnu, help me simplify it, please.
mu square over L.
mu square over L. All right, that's it. So this is a school version. All right. In fact, why your school teacher will derive it this way, right? It's because they are using a textbook, and the textbook derive it this way. But this textbook has a mistake, and I think some of you are aware of this. Let me ask Vishnu. Vishnu, when you studied this, it was last year, right? When you're in J1, am I right? Just confirm. Okay. Have you ever asked yourself why is it the time, right, is equal to the time between the two consecutive collisions? Isn't the time per unit time, shouldn't the time be the time when the molecule touch the wall during the collision, change the momentum per unit time? Am I right? What is the time between the two consecutive collisions? Have you asked yourself that? Why did they replace the time with 2L over U? 2L over U obviously is the time between the two consecutive collisions. Am I right? Have you asked yourself this? Why? Never asked before? What do you think? All right. If you all never asked this question before, please, okay, I'm okay. Please use your school method. This is very easy to understand, even though the concept is wrong. But you will get answer mu square over L. Perfect. Very nice. Now, if you are concerned, meaning before I even ask, when you studied this chapter last year, you say, hey, how can it be? Because m delta v delta t, the time should be the time during the change in V, right? That will be during the collision. Why is the time between collision? If you have this question, then you listen to me for the next 3 minutes. If not, please do not ask any, don't listen to me, all right? Now, I want to talk to those of you who know that the time should not be the time between collisions. What are they doing? Now, let me tell you the truth. Basically, right, when you want to find the force, you can write down, all right, m dv dt. If I write this equation, right, it's missing something. What is it missing? Let me ask Jerry. Jerry, do you know what is missing from this equation? When I want to find the force between the molecule and the wall of the cylinder, one thing is missing.
I have no idea.
You have no idea. Okay, never mind. Let me just tell you. Big N. Big N represents the number of collision. How many times the molecule collide with the wall? Am I right? Do you remember just now I was telling you that this is not easy, and a lot of people do not understand this. In fact, if I highlight this N over T, Jerry, in this case, right, N over T, right, refers to the what?
Number of collision per unit time.
Am I right? So you understand what I mean. Obviously, you agree with me that if the same molecule hit the wall 10 times, I should put a 10 times m dv dt. True, So this 10 collision, right, per unit time is the number of collision per unit time. So what we really need is to find the number of collision per unit time. All right. So basically, right, to find the n over t, I put it down here. Again, it's for those of you who have question about why they replace the t with 2L over u. Why? Then I'm answering you. If you have no problem, please don't listen to this part. Otherwise, it get you more confused. All right. Number of collision per unit time, which is over here, yellow color. I want to show you how to get it. Do you agree that? Let me ask you, Louis. If the time between two collision, right, the time between two collisions is 0.1 second. How many collisions are there in 1 second? This next question. If time between two collisions with the same wall is 0.1 second, how many collisions are there in 1 second?
20.
I think you take, is it 10, right? You take 1 divided by 0.1, am I right now?
Yeah.
With the same wall, I'm not talking about the other wall, I'm talking about this one. If I go to the left and then I come back, it's 0.1 second. All right? Left and right is 1 second, 0.1 second. Then how many collisions are there in 1 second? You take 1 second, divide by 0.1, you know that there will be 10 collisions with the wall within that 1 second. True? Okay?
Yeah.
So assuming that you know, again, I put out 1 divided by the time. You should divide by the time between the collision. And the time between the collision, right, is what you all say is 2L over U. Am I right? Okay? So basically, right, 1 over 2L over U becomes U over 2L. So this thing, can you highlight this one? Will becomes what? U over 2L. And that's why you will have this guy called mu squared over L. And of course, this one is the same thing. This is 2U. All right. See this? So this is the actual derivation. If you have no issue with the first one on the left-hand side, no problem. Continue to use what you have in school. Okay. By right, it should be this one, the right-hand side. Okay. That involves the number of collisions per unit time. All right. Now we managed to find the force on the wall due to one molecule. It's mu squared over L. So please take note that your mu squared over L, right, have already taken into account that my molecule will hit the wall more than 1 time in 1 second. It have already taken into account. All right. Just that you may not be able to see it if you use this method. Okay, but you will see is that I actually take into account of that. Okay. Mu squared over L. So what should I do? Let's say I would want to find the force by n molecule. Because basically, right, if there are 10 molecule, Louis, if there are 10 molecule, right, what will be the total force by the 10 molecule? It will be how many mu squared over L?
And
It will be n times mu squared over L, right? So that 10 molecule, you times 10, huh? But wait. Let me ask you something. For the gaseous molecule, right, is the mass about the same? The mass the same, right? Should be the same, right? Is the speed the same for all of them? Despite being in the same environment, is the speed exactly the same? No. So if the speed is not the same, what do you think I should do? I want to find the total force by all the molecules. So you are right. I should multiply by the number of molecule. This is number of molecule. Okay, and then I will multiply by mu squared over L, right? U squared over L. Am I right? But this U, because of the speed, is actually not exactly the same, right? What should I do to the U square? What should I do?
find average.
Average of the square of the speed, am I right? So what do you call that? Average of the square of the speed. What do they call that? Name is called
Mean square.
mean square speed, you mean? Huh?
Oh,
The mean square speed.
yeah.
So therefore I put out here for you, mean square speed. So you're saying that I should multiply by the mean square speed. Okay. All right. And I think Louis actually knows what I'm going to do later on. She knows that it's better to express the answer as a function of root mean square speed. It's easier for people. Then they will understand. So therefore, I'm going to use a red color, and then I write down root mean square speed. But I also understand what root mean square speed. Root mean square speed means what? Step 1, if you don't know, you write down, you square it. Step 2, you mean it. All right. And then step 3, you square root everything. So when you use the root mean square speed, you say, all right, you know what? The total force by all the molecule is N U square over L. But the U must be root mean square speed. What happens is that when you square your root mean square speed, look at step 3. When you square that root mean square speed, right, you remove the square root. And when you remove the square root, what you get is actually the mean square speed. All right. So we actually mentioned about that. All right. Okay. Perfect. Eric. Now this big N again, can you remind them this big N represents the what? The number of what?
Collisions.
That's what I want to tell them. Thank you. We are saying that this N is not the number of collision, right? Because there are 2 N. That's why this is the number of molecule. This one, the one on top. The one on top where I was telling you that this one is the number of collision. So they are different. Okay. But anyway, if you don't understand what I'm talking about, over here on the right side, you can just ignore. Never mind. Okay. So we are now here. Oh, good, good. So that will be the force by all the molecule when they collide with the wall. Good. But then we have the third problem. The third problem is that Estin, you help me with this. You know, under kinetic model, we all know that the molecule are moving in random motion. Okay. Now, actually, the notes, right, in your lecture notes will have this box. Do you see the same box? They use the same color also. Right, because it's to show people that they're moving in random motion. In fact, you know what? Should we draw in for them? Basically, right, on average, the molecule is moving like this. So that's the speed. Let's write down V, the speed here. So it's a three-dimensional space. Now, Estin, I want you to help me with this, and to make things easier for the rest of the student. You say 3D space is actually hard for them, you know. I think what we should do is that we all should start off with a 2D space. Do you think so? Let's talk about 2D. What's two-dimensional? Meaning, everyone draw in here. Let's say that the molecule can either move along the vertical or the diagonal axis. There's only SY only. There's no Z axis. Don't have. Let's say my molecule only go left, right, up, down, or diagonal. He will not be able to go out of the paper. You know, okay? Easier for them to understand. Okay. Now on average, right? On average, the molecule, I don't think you will think that all the molecule is going horizontal, right? If all the molecule is going horizontally, then that'll be easy for me. That will be the speed I want. That is the speed I want, isn't it? I want a horizontal speed. No. That's horizontal speed. That's what I want. But you know that some molecules are moving vertically as well, right? So on average, we say they move at a diagonal. So if it's the average, right, what should the angle be, Estin? If you want to show them that on average, they are moving along the diagonal. All right. So what should be the angle be on average?
45.
45. So we want to tell them, we tell the class, can all of you make the assumption that the gas molecule are in random motion? So they are all moving on average at an angle of 45. But I of course know that some of them are moving at angle 30 to the horizontal. Some move at angle 70 to the horizontal. I do understand that. All right, but on average it's 45. So we use averaging, no choice. Okay. By the way, you know that the velocity is a vector, right? So Estin, vector can be what? Vector? What's so special about vector?
Can be resolved.
Can be resolved. So good, you know. So if you resolve, use which color? So let's say I resolve it. So it got two perpendicular components. And you mentioned angle on average is 45, right? Okay. So let's say just now what you're using, right? Just now your U, let me show you over here. The U that you're using, right, is actually the horizontal velocity of the molecule. You know that this is ridiculous. Obviously, this is the horizontal component of the velocity of the molecule, because your molecule will not be moving perfectly horizontally, right? So so this U is a horizontal component of the velocity of the molecule. So therefore, by right, I will call this thing U. Keep it simple, I call it U. Now this is U. This is U. So from the two-dimensional space, right, Athena, can you help me use Pythagoras theorem and give me the equation that relates the V and the U? Can you do that for me? Athena?
U cosine 45 equals
Oh,
to...
good. Wait. Very good. Cosine 45, very good. But Pythagoras theorem better, okay? Because same side, so easier. Yeah. Go on.
U
square?
2U square equals V square.
Perfect. Okay, good. That's what I want. Very good. So, Athena, I slowly guide you. I think you also know, you don't need me to guide you, but you can see that the U square, right? Just what we need is actually the U square, right? We need a horizontal velocity to find the force mark, right? So this U square that I use, right? Actually, you want to express it in terms of the actual velocity of the molecule, which is V, right? By right, I should replace the U square with what? With what?
Half V square.
Half of V square, am I right? By right, huh? By right. But by left, this is a three-dimensional space, right? Three-dimensional space, right? So I should replace the U square with what? Is it half of V square or what? 1 over what?
1 over 3.
1 over 3. 1 over 3. Anyone do not know why 1 over 3? You don't know, I can help you, no problem. So you see U and U, right? Of course, this 2U will give you this one. Am I right? Will give you this one. So this one will be what? Square root of 2U square by Pythagoras theorem. Am I right? Then this one is also what? This one is also U. Because if you're talking about average, then we will assume that the horizontal and the vertical and also the velocity along the x-axis will be the same in magnitude on average. So therefore, at the end of the day, right, you want to find this velocity, this v, right, will be actually equal to 3 times of u squared. I give you from 3-dimensional point of view, right, which is what your school teacher will do immediately. They go like this, they'll give you this equation. But if you can understand how I get it in the 2-dimensional space, then you should be able to understand how I get it in the 3-dimensional space. So Athena, just like you were saying that I should replace it up with 1/3. So this one, I just circle this out, okay? I can write it down over here. So the force is Nm/L, and you mentioned that I must replace it to 1/3. So V squared. I can replace the U with the actual velocity. This U is the horizontal component of the actual velocity of the molecule. Yeah, but I know that the question always give you the V, the velocity of the molecule. They will not give you the horizontal velocity. They are not so nice, right? So therefore, I help you replace this horizontal velocity as a function of the actual velocity. Is that clear? So it's 1/3 V squared, huh? All right, okay. So now we are almost done, So therefore, we're going to the last part. Shemaine, my last part, I will need your help. I want to find pressure actually. Give me the formula for pressure.
Force over area.
Perfect. So you want me to use the blue color divided by the area, right? So let's just cut short. Let's save some time. When I divide by area, then I got L and area at the bottom. What do you get after this? L and A, you will get what? Volume. So then I copy the rest out. N, M, the root means square, speed. I put a square there. I know there's a 3 below, and you're saying volume. Oh my God, this is a volume, you know, but this is V. Well, you know, I better put a big V to show its volume. So you don't know, I will spell out volume, okay? So that you know that they're not the same before you start to simplify it. Shemaine, now you look at your blue color nice equation, right? What do you think can be combined, can be simplified in this equation? What can be simplified?
Mass and volume.
Mass and volume. You mean this one, huh? This one and this one? Is it this one?
Yeah.
You sure? Do you miss out someone?
N.
Big N also, huh? Am I right? Because big N plus small n is the mass of the gas, ma. That's why right from the beginning, I was tell you the difference between big N and small n. That's the reason. So you're saying that should we use red color or orange color? I just got it. This one, right, is actually to get it is what? Density, which is here. Density. The density is big N plus small m over volume. You can write it down. That's it. We have our equation P equal to 1/3 rho V squared. This is obviously not easy to understand on your own. Because when I was a student, when I was taking A-level many years ago, this is also in our syllabus. And I remember that me and my friends do not understand a thing about what the teacher is talking about in this part. So I guess it must be also very hard for you right now. Okay, but I have shown you step by step on how to get this equation. And I tell you what, I got a very good feeling. I got a good feeling that they're going to test you on this year. All right, it's so important. Okay, all right. Now, let's look at this. We have this equation, PV equal NKT. This one actually is from the ideal equation of state. So big N represents the, let me ask, Tony, this big N represents the what? Number of what?
Total number of
molecule. Or particle. Actually, particle very safe, right? People would ask you, are you talking about atom or molecule? You know what the secondary school, sidetrack. You know, secondary school spend so much time on molecule or compound, element and all this, right? All this is pretty much useless now. All right. Okay, so you just say particle. Actually, in physics, you don't care whether molecule or atom or what. You just say particle. So number of molecule or number of particle, PV NKT. And I want you to look at this equation, the equation 2, which is what you derived just now. Zheni, if you look at both of them, right, do you see something that is similar between the two of them? Why is it that I bring back ideal equation of state in this one? What's similar between two of them? Number one, they have a pressure, they got pressure, right? They got pressure, right? Number two, this one got a volume, Where is there a volume in this equation?
Yes.
Yes, can you help me? Can you help me make it? Can you help me put it in here? Where's the volume? Where's the volume?
Density there.
Density there. I bring it out. I bring it to the left hand side easier so that you can see it's the same. We compare whether it's same or not. All right. Then equal to then what? 1/3. 1/3 what? And then number n m and then v squared. And the v is RMS. Let me check. Did I make any careless mistake first? Let me check.
Got more volume. Let me see.
My volume there already. I put it so that it's the same for you all. And then you can see it's the same. I do not want everyone to lose the big picture. I will always want to go back to this page and say, hey, you know what I'm doing or not? I proved to you this equation just now, and I spent a lot of time on it. And now I want you to know that this equation pressure and this one pressure, they are all interlinked, right? I want you to combine the two equations and you see what you get, all right? Let's see, I can combine it, simultaneous equation, P and V is a common factor, right? Let's see. If we have PV on both equations, am I right to say that this NKT for equation 1 will be equal to 1/3 big N small n V squared? Is that right? This is for equation 2. Correct or not?
Yeah.
Clear? Very legit, all right? What should I do now? What should I do?
Cancel the N.
Cancel the big N, I agree. Very happy to cancel the big N. Then what should I do? Game over, finish, done. What am I trying to prove? What am I trying to prove?
I don't know.
You don't know what I'm trying to prove, are you sure or not? You must be blind. Let me show you. What am I trying to prove?
VRMS.
No lah. Girl, I'm trying to prove what? What's this? Very similar to what? Something mv squared. What is that?
Kinetic energy.
Average Ke, right? Correct or not? I try to prove to you average Ke half mv squared Am I right? How to make this a half? It's not a half. What should I do? How to make it a half? What should I do? Times what? Multiply by what? What? Use calculator. You
Times 6.
That's 3/2 is it?
Sure.
3/2 That's 3/2 Okay. All right. So therefore, don't mind. Can I make the Ke on the left hand side easier for me? And then you got 3/2 KT. And what's this? The average Ke. What did I just do in that 10 seconds? I've proven to you the last equation, the third equation, that the average Ke is 3/2 KT. That will be the temperature is in Kelvin. Am I right? Nice. Are you happy with this? It's so you know what? I actually go past the entire A level without understanding a single thing in this page, in this part. So I'm actually very happy every time I look at all this maths over here. Okay, we have proven this equation over here. 3/2 KT. All right. And let's do some question. Now you all have your thermal ninja question, right? You also have it all. Okay. You know that in the additional lesson I was doing question 1 with round 1 with all of you. Anyone need me to go through any question in round 1 that if you don't understand? You can put in the chat group. If you need me to go through the one that I went through in the lesson, this one. Oh, okay. A lot of you still actually see me after the class, and it's still asking me about molar mass. That I explained to them. Molar mass 32 gram. If you use the unit gram, right? If you use the unit gram, then this 32 gram refers to the molar mass. That's the mass of 1 mole. And the mass of 1 mole is independent on how many mole you use. I don't care you use 100 mole, the molar mass is still 32 gram, all right? But however, there are 2 different units for the 32. You use gram, then the meaning will be molar mass. But if you use U, 32 U is 1.66 10 minus 37. If you use a unit U, then 32U will be the mass of 1 molecule. So what unit you use? In school, your JC teacher, secondary school teacher would normally want to use gram. and they will use it as a molar mass, obviously. But I'm saying that there is another way to look at it. I want to let you know this unified atomic mass, the small letter u, which is this number, is a mass of a proton. So if 32U will be 32 times the mass of the proton or neutron, and that will be actually the mass of the molecule as well. So let you know the difference over here. So in case you still have question on question 6. Any other question? I'm looking at the chat group. No one asked me to, no one want me to go through any question? Then I will go over to question round 2. So let's do round 2 together. You have the initial temperature, you got the final temperature, and you have the pressure of the gas, I put off P. You also find the change in mass. Can I ask you all to do it on your own right now? How to find the change in mass? This question confirmed will be using PV equal to nRT, the ideal equation of state. And look at how nice your mind map is. Do not underestimate one single page like this. It consists of all the possible questions. Look at this. They give you mass of the gas, right? They give mass of the gas. They want you to find the change in the mass of the gas. See, it's here. You replace the number of mole with m over mr. M over mr. I feel that the teachers, right, especially the chemistry teachers in secondary school, are giving this mr too many different names. Sometimes they call it molar mass. Sometimes they call it RMM, relative molecular mass. Sometimes mass number. So this number, right, really have too many different names already. Okay. Now this is the mr. Okay. But remember, this one, the unit by right should be gram per mole. The teacher give it to us in terms of a kg. So I better write it down for you. It's kg per mole. Normally they will give it to me in gram. Normally they say 30. The mr is 30. The RMM is 30. Can I ask you to give me your answer when you have it? What's the change in the mass of the air? Not bad, because they give you the difference, the different temperature, and they give you the constant volume. The pressure is given to be the atmospheric pressure of 10 to the power 5 Pascal. The temperature change from 180 degrees Celsius to 25 degrees Celsius. It cool down. Having some answer, and the most I want to tell you something very surprising. Okay, in fact it's good because you all have additional lesson this year. Last year I give the student to do it at home, but I didn't go through this with them. This one I can guarantee you, if you do it, you will make a careless mistake. And all of you who submit the answer just now, right, all of you, your answer is wrong. What is the common careless mistake? I give you a hint. The hint is that do not use shortcut. If you want to use shortcut, I'd rather you take out common factor. Okay? You want to find the difference in the mass. Do you think you can just sub in the difference in the temperature? And then you think you sub in delta T here, you can find delta M? Is that the way you do it? Sub in delta T, then find delta M. when you make mass the subject of the equation, you get PV mR over RT. You check. Is that right? Step 1, make mass the subject of the equation because you want to find mass. Very intuitive. That's what you should do. And temperature change. Temperature is a variable. So I highlight for you the variable. Can we say that delta M is equal to blah, 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 blah over delta T? Cannot. Definitely no. What you want to find is M2 minus M1, the change in the mass. And that will be PV mR, and the big R is all common factor. The only variable is the T. Throw in over here. 1 over T2 minus 1 over T1. Don't need to use shortcut. We have a problem today because the mass is inversely proportional to temperature. All right? And therefore, what you get after you take out common factor will be 1 over T2 minus 1 over T1. Your T2, of course, you all must remember to change to Kelvin. Double mistake if you forget this. This one, change to Kelvin as well. 180, 180. And then you throw in all the other number. You will get the final answer, which is the delta M. All right, a lot of you are getting the correct answer already. Zero point zero four. Let me talk to Joanne. Joanne, where are you? Okay.
Here.
Can I have your surname?
Lim.
Now, Joanne, a lot of people at home.
Yeah.
So basically, we know that the answer is actually 0.04. I put it down for you. Now, I want to ask you one question, Joanne. Let's say, for example, today I've changed my question. Let's say today my temperature is constant, okay? And then the volume change. Then the volume change from 10 to 15, okay? Volume change from 10 unit to 15. Then can I, if you want to find the change in mass, can I just throw in the change in volume inside? Let's say the volume change, but the temperature is constant. And the volume change from 10 to 15. So can you tell me how much is the change in volume?
5.
5. Then can I throw in the 5 here now?
Can.
Can. Then can. All right, good. Yeah, this will be okay. All right, because if the variable is proportional to directly proportional to the other variable, can. So you take out common factor, right? Let's say volume change, right? You take out common factor, you get V2 minus V1, no problem. Am I right? True. But if your variable is below, that's a big problem. It becomes 1 over T2 minus 1 over T1, right? You cannot. Now, if you don't like to hear what I'm saying, right, then don't listen. Just don't use shortcut. Just take a common factor, you will know. All right? Just don't use your own assumption. Easier for everyone. Okay? So answer is 0.04. Very good. Now let's go over to the second question. Shemaine said, let's do this question together. You are given the mass of the nitrogen. So maybe I write down the mass of the nitrogen over the mass of the oxygen is 28 times. So it's 28 times higher. No. What? So sorry. Made a mistake. I didn't read the question. No, they are actually giving us the mass of both of them. So I just circle them. Okay. So you got nitrogen mass. I got the oxygen mass. That's good. I also give the ratio of the root mean square speed at the particular temperature. Let me have the equation that I should use.
Oh. K equals to 3 over 2 KT.
Ke equal to 3 over 2 KT. Perfect. K equal to 3 over 2 KT. Let me just write down. If not, I will just write down here for you, okay? So basically, you're saying that the average Ke is equal to 3 over 2 KT. Okay, good. And with this, you know that the temperature is actually different. You can see that 180 and 25. Obviously, if temperature is different, I will put down, I highlight this as a variable. And Charmaine, can you help me replace my K with in terms of root mean square speed?
Half mv square.
Half mv squared. The v will be the root mean square speed.
Yeah.
Correct. Good. Okay. So basically, what is the variable? Besides the temperature, which one is the other variable? The speed. That is what you want to find. Am I right? And the mass, are the mass the same?
No.
The mass also not the same, right? Oxygen and nitrogen, not the same, So
Yeah.
mass also not the same. So mass is important also. Anything else that's important to you? No need really, right? All this is not important. Okay, let's go. Let's get ready. So it will be the ratio of MV equal to the ratio of temperature. All right. So let's go. Temperature T1 over T2. The temperature here is 180 plus 273.15. Here will be 35. According to the question, you choose the Kelvin. Yeah, I forget. I should let you do it on your own. Then you will see whether you will remember to choose the Kelvin or not. Okay. And this one will be what? The mass of the oxygen and the speed is square, right? So I just put that over here. Should we just throw in the number? You want the oxygen to be on top, and that will be 32 U. You want the nitrogen to be below, and that will be 28 U. Let me check. Okay. You're asked to find the ratio of the speed. You can get it, of course, from here. Remember, later on, you must square root everything to get the answer. The ratio of the speed. Let me have the answer. Maybe Seth, can you let me have the answer for the final ratio?
I am not done yet.
The rest of you who are done, you can go on to question 3 and fill in the table for me. Very simple. Yeah, what's the answer, Sash?
Is it 1.15?
Perfect. Okay, there will be 2 marks like this. So just to let you know the learning point, just now I asked what is the equation that I should be thinking about. She gave me average KE is 3 over 2 KT, and that is good. That's quite important for me because it shows that she understands that the ratio of the speed depends on, of course, the temperature, and therefore she's actually giving me the equation of the average KE and the temperature in Kelvin. Okay. Now let's go on to question 3. Everyone fill it on your own. Fill in the table on your own. Very simple question. AB, I highlight in yellow color. And this one involves first law. So let's stand by first law. So since supply is 0, the work done is expansion. So just for fun, I shape for you this area to show you that I understand. When you say minus because it's expanding, volume increase, and that will be minus 300. That is the work done on the system. Obviously, that means that the internal energy, the change will be minus 300. Change in U equal to Q plus W. The first one. Let me highlight the second one. And that will be from B to C. From B to C, it is vertically downwards. There's no work done. The work done is 0. Why did they fill it in for me? I should be the one doing it. They fill in for me. I don't know why this question give us 0 here. So the delta U is minus 450, and therefore the heat supply will be minus 450. Okay. And we're going on to C to D. C to D. They give me a positive work done, 650. I can see that. If I were to shade this whole thing, you all don't have to shade that. I just do it for fun, just so that you can remember what you learned. This area is 650 positive because it's compression. And then of course I can find the heat supply, and obviously it's 0. What does 0 mean? Adiabatic process. Or you can say that the container must be insulated. 0 heat transfer. Okay. And Demi, hello. Demi, the last part is D to A. Let me change the color. D to A. Will you be able to help me find either Q or work done or change in U? Which one can you help me find first? Which one?
Work
D to A.
done,
Work done. Is it a plus or minus?
minus
Very good. And that will be the area under the entire graph, all the way to the x-axis. What will be the area of a rectangle? Have you calculated that?
750.
750. Perfect, perfect. Then after you find work done for me, what will you find? The Q or is it the delta U?
Delta U.
How do you know what's the delta U?
Is it minus 100?
Yeah, minus 100 is a very good wrong answer. Meaning people will always get minus 100. I don't know why. They will always get minus 100. How do you get minus 100? Is it because you add up the number here, you get minus 100?
Yeah.
And then this one should be what? Because the
100.
total should be 0, so this should be plus 100. All right. A lot of them give me minus 100, in the exam. Okay, should be 100. So that the total delta U should be what? Should be 0 if you combine the complete cycle. In one complete cycle. You add up, it should be 0. Which means that, Demi, last thing for you. This one will be
850.
850. Nice. Good. A-level typical question. Okay, question 4. Atia? Question 4. When you see this word sudden compression in exam, what does this tell you?
Adiabatic process.
Say again? Adiabatic process.
Yeah.
Are you implying that the heat transfer, the Q, is equal to
0.
0? Can you explain, 1 mark question, why do you think that sudden compression of a gas is actually associated with no heat transfer? 1 mark. State why. Common sense. Don't know what to say, is it? Why?
Yeah.
Huh? Seriously, you really don't know what to say? You don't know why you say what you say?
Yeah.
Are you sure? How about Li Yan? Why sudden compression? He's very strange, he know the answer. He know that sudden compression means that Q is 0. Yet he do not know why he know it. Why? Because
I also only know it's
okay, heat transfer, complete the sentence, require
time.
CD, right? Of course, whether I transfer heat to you, I will need time to slowly transfer heat to you by conduction, convection, and so on. Am I right? So if the thing occur all of a sudden, it also means that there's no heat exchange. So your adiabatic process, right? If I'm you, you know what I will do? I will go back to the circuit and close, right? I will go back here. See? Then I will go back here. Then I will go over here and then I say, hey. One is insulated, right? The other one will be what? Quick or fast. Quick. Or you put on fast. Then I understand. Every time you say quick or fast, I know Q0. Meaning the graph will be very steep, steeper than the isothermal. Okay. Very good. All right. Now, they say it's a compression, and that means that they're going to push the piston in. And the question also tell me over here is insulated, that double confirm that Q is 0. Okay. By right, they don't have to tell us it's insulated. All right. Okay. Basic quick means there's no Q. So obviously the graph is going towards the left, because you go down here. And as you all mentioned, it's an adiabatic process, which is Q is 0. Go on, and everyone proceed with part 1. Use the equation of state and check whether the temperature go up, down, or constant. Go on. How will you solve this question? 1 mark only. Li Yuan, get ready, Ken. Sharon, get ready also for this part. How do we know whether the temperature go up or down? When you move from A to B. Okay, Li Yuan, first thing first, do you think that the temperature increase or does it remain the same or it decrease? What's the answer? Li Yuan?
Decrease.
Go down. Go down. How you tell that the temperature go down?
You calculate the PV.
Oh, so the PV at B is smaller, is it?
Oh, increasing.
I draw arrow for you. Hey, Li Yuan, first step, draw arrow first. Okay, y'all don't care, right? Compression is very important, so you tell you what A to B or B to A. So you calculate the PV. Okay, this is a state question. You don't have to explain. If you have to explain, you must tell them that first of all, PV is nRT. That means that the product of pressure and volume is proportional to temperature. All right. Then you must show them clearly. PV at point A, PV at point B. You multiply the PV at both the point A and B, you will get answer 250 and 480. And it clearly show that the PV increase. Temperature must go up. Okay. So that's the first part. Sharon, do you get the same thing?
Yeah, but I didn't use this method.
Then what method? How come you know what other method you have?
Nothing.
Huh?
No, nothing.
No, tell me, don't pretend, tell me what method you use. Say, I'm getting ready right now.
Cause I think it's wrong, but then like
No, you're right. You just tell me. You use what? Change in what?
cause like work done is negative.
Yeah. Wait. Give me the equation first. Q plus W. Okay. So you use another method. You saying what? Cause compression, work done is what?
Negative.
Wait. Sharon, look at me. Look at me.
Oh,
Compression.
positive. Sorry.
Positive. All right.
Yeah.
All right. And then is there any heat transfer?
No.
No. So from that, you're telling me that the delta U, it looks like a Q. Delta U is positive or negative?
Positive.
Positive. Which means that the temperature increase, is it?
Yeah.
Because the internal energy is actually 3/2 NKT. Basically, it's proportional to internal energy, right? So temperature increase. So do you think your explanation is correct? Say yes. Yes. But however, do you think you get 1 mark? No, why? Why is it that you didn't get 1 mark? What's the command word in the question? Command word.
Oh.
Considering, up to your own consideration. What's the command word? Using equation of state, 0 mark. Very, very common problem. Now, thermal, right? The entire chain of thermal, right? Actually, I can derive the same answer using equation of state, PV nRT, or first law. In most of the question, I can use either method. So please look at the command word over here. So temperature go up. Now let's go over to the next part. And I want your help to help me draw the graph, to complete the graph. Use different color. This one is being cool and in the same position, same volume. Help me draw. It's a cycle. This is a cycle. You return back to the same point. Complete the two paths to form the cycle. Expand, volume increase. Temperature the same. Go on. I give you a hint. With calculation. You do need to calculate. Calculate what? You should know. Once you draw, you will know. Process 1. Volume the same. So how? Where should I stop? Volume the same. And then you go down, right? Until where? Where should I stop? I do not know. It's a question mark. I do not know where to stop. It's being cool. You may want to write down. Everyone should write down. Q plus W. So it's the isovolumetric, the work done will be 0. And when you cool it, of course, the Q will be negative. And when Q is negative, it means that the delta U will also be negative as well. So that's why the temperature will drop. Your PV will drop. It will go down vertically. It will not go up vertically. It will go down vertically. So where will you stop? I don't know. This is a grade A question. But look at the green color. Process 2 is the third path that gives you the last part of the cycle. Constant temperature. Okay, all we should be done. Are you done? Are you almost done? Jenna, can you help me with this? All right, I have a problem. I know that after the adiabatic process, I will go downward at constant volume and temperature will drop obviously because the PV will drop and I don't know where to stop. All right. Oh, by the way, Jenna, your background is very nice. Oh. If I'm you, I will say, oh no, that's my house. All right. Okay. Coming back to here, where should I stop? How do I know where to stop?
Stop at the same pressure as A.
Oh, stop like that. Okay, then later on the last part, the green color will be like this horizontal, is it? You want it to be this way? Do you want it to be this way? Isothermal, isothermal, temperature the same. Is it isothermal?
No.
What does isothermal tells you? It tells you that temperature is the same, right? So when temperature is the same, what does it mean? What does it mean? How do you know temperature is the same? What gives us an idea whether temperature stays the same or does temperature change?
Pressure and volume.
Pressure and volume. Am I right? So just now at point A, right? Do you calculate the PV? You did, right? If not, how you do? Am I right? What do you get? The product of P times V.
250.
250, right? Which is here. Which is here, oh. So which means that you also must have a PV which is equal to 250. True, this point. This point C. But I know the volume of point C. Can you read out for me? What's the volume of point C? Volume?
1.2.
1.2, good. So I help you. So this is volume is 1.2, right? You want to know the pressure, right? You want to know the pressure. Okay, and it will be also equal to 250, am I right? 250. So good. So can you help me calculate what will be the pressure? Since I know that the volume is 1.2 from the graph, 1.21, 1.2. So I need to know what's the pressure. I understand the PV must be 250.
2.08.
2. And then at 2.0 can already, 2.0, okay? So I must hit here, right here, see? Here, right, this point. Agree or not, or disagree?
Yeah.
Agree, good. So now I erase everything, okay? Then I draw this all the way, stop here. Then here, right? Over here. Nice. So this green color one is the isothermal. Should we write down? Isothermal. And this one is the adiabatic process. Where Q is 0. Can you see this? And those of you who are done, can you always look back at your secret enclosed and check that did we cover the same thing? See this? That the adiabatic process is actually steeper compared to the isothermal. Can you see? Because there's a change in temperature, the PV will change. This one, the PV remains the same. Okay. Very nice question. Just for fun, let me ask. Inshio, in a complete cycle for fun, it's not inside here. In the complete cycle, right, what will Q be? Plus minus 0 in the complete cycle. One cycle.
Zero.
Huh? In the complete cycle, Q is 0, is it? Q, I asked for Q.
What
is 0? Can you tell me?
W.
Inshio, look at me. Inshio, you look at me. Face me. Hello. Have you attended my lesson or not? The additional lesson.
Yeah.
Then what is 0 in one complete cycle? Which one? There are only 3 things. Just like you say Q, I say wrong, you say W. So what do you think it will be? Which one is 0?
The change in
U. Why is that so?
Yeah.
Why is it that in one complete cycle, change in U is 0? Why?
Because is it like it comes back?
Comes back, give you how many marks? 1/4 or
Like,
1/5?
It's like a cycle.
Yes, you're repeating my question. I want the keyword.
So increase, then like it's like decrease and increase.
Like that, how to give you mark? 1/5 mark. Return back to the same state. Return back to the same pressure, same volume. So meaning you are returning back to the same temperature. So means that your K will be the same as before. Is that right? So your internal energy will be the same as before. There's no change. Okay, now Hinsho.
Yeah.
All right. Can you tell me the total work done? Is it plus minus or 0?
Is it minus?
Negative, why? Because the red color one is negative work done, right? Green color is, sorry, no, wrong, not minus. Red color one is positive work done, am I right? The green color one is negative work done. So the positive work done is more than the negative work done, so it's a positive, all right? And then this one becomes negative. Okay, now. You sure you want to rewatch the video or not?
Yeah.
Yes, or you should, okay. All right, now let me, I'm done, let me quickly make an announcement. If you were to go to PMC Digital and you log in with your own account, you'll see that you will have access to the course which is called the May-June holiday additional lesson. So the May-June holiday additional lesson, I have uploaded the video of the additional lesson as well. If you need to rewatch it, by all means rewatch it, okay? And the solution for the takeaway question has also been uploaded in the same platform. And I also want to let you know one good news. Due to requests from students, some of you feel that, hey, I want to revisit some chapter. For example, I am having an EMI test very soon in June. because when the school reopened, they're going to give me a lot of tests. I need to revise EMI. But last time when I go through EMI in PMC, actually I know everything about EMI. I can solve all the questions, but it has been some time I forget. So I hope that I can watch EMI again. So if you hope that you can watch EMI again, very easy. Go to PMC Digital, go to J2PH, and look for your EMI lecture. Look for the EMI lecture. What lesson is that? I'm not sure what lesson. Maybe it's lesson 12 of the year. Then you just tell the admin, I want to watch lesson 12. Then the admin will give you a coupon code. By right, you have to pay 120 USD, right? So they give you a coupon code, and then you can submit the coupon code. Then you will have a 100% discount. Then you can watch back the lecture. Okay, I repeat, I'm giving an example. If you say you need EMI, and then you know that all the lecture has been uploaded to the PNC Digital, right? And then you want to watch it again. You have attended the lesson, but you want to watch it again to get ready for the test. We give you a free service. We let you watch it again, but of course, we need you to WhatsApp the admin and ask for the coupon code, and then they give you the coupon code, and then you key in. You don't need to pay. You can enroll. Okay, so that is one update for you. Any one of you have tests? Maybe I ask you, so why did your school teacher say they are going to give you a test soon?
Yeah.
Good. When will that be? When is your test?
Like late June.
Or late June. Late June is okay. Because by the time late June, right, I will have already revised the entire syllabus. That includes the JC2 syllabus. You know, EM, electric field, EMI, CUE, DC, quantum. I will be revising with all of you as well in June. So, but in any case, you need any lesson that is in the past, that's over already. You want to watch it, we let you watch again, no problem. Okay. What other thing that I want to say? Okay, I think that's all. So yeah, can I ask, any one of you have watched the additional lesson 1, right, from the webcast, from the PNC Digital? Who? Raise your hand. Okay, so certainly you watch it, and who else? I want to check who watched webcast instead of attending live here. Who? None of you, none of you. So certainly, when you watch the webcast, right, you realize that in the Suntech lesson, that was last year, I held the lesson in Suntech, right? I actually conduct a quiz, a competition, an 8-question quiz.
Yeah.
And then you have watched the video already, right? So it means you know the answer. So later on the game.
I didn't watch that part.
Oh, you didn't watch that part? Okay, that's good. Then you can play the game. If not, you cannot play it. All right. Okay, because you don't know the answer. Now I'm going to send a PDF for you, and give me a minute. Actually, why you choose to you jump over the video? Why you didn't watch that part? Why?
Oh, I thought the lesson was on like another day, so I missed that lesson.
Okay. Now I'm going to break you up into groups, and I'm going to send a PDF to all of you. Now you can take out, you can open the PDF right now. Okay. All right, all of you, open the PDF already? Sunny, do you see, have you opened the PDF?
Opening.
So slow. Shamin Court, have you opened the PDF?
Yeah.
Okay. How many questions are there in the PDF? How many are there?
8.
8 questions. Okay, do you see a coffee cup there? In each of the questions, that represents the level of difficulty. All right. 8 questions. There'll be 2A, 2B, 2C, 2D. Okay, I'm going to bring you up. Okay. When I bring you up, you'll know who is your group member. No problem. Okay.
Sir, all the answers are in there.
Oh no. Okay. Good. What happened? All right. Don't need to play. Okay, never mind. Come back to here. Okay, everyone, let's go through the question then. Oh, why all the answers are there? Can I just erase? Okay, let's close this. Let's close this. Everyone, close this. Close this. And I'm going to give you the one with empty one, so that's easier for you to learn. Okay, now you all have the answer already. Okay. Now in. Okay, I'm gonna send you one more file. This one with no solution, so that it's easier for you to follow without any hint. It'll be better for you. Okay. Please accept this file instead. Unfortunately, let's reload this. All right. Okay, look at question 1. Okay, don't need to look at the answer, just look at here. We can do it together. Okay, do it together. Nickel cell. Okay, let's do it together. Now I have a pressure, I got a volume, and they give me S, Q, and R. They give me the work done, and they give me the Q. So let me just color shade this S, Q, and R. S, Q, and R. Three joules of work done. Heat transfer is 8. Then after that, they go over here and tell me, how about S, R, and P? S, R, and P. Direction is like this, S, R, and P. Then they give me the work done. You're asked to find the Q for S, R, and P. Everyone try on your own. Okay, try on your own. Okay? Don't need to look at the answer, just try on your own. See whether you can do it on your own. What should I do? S, Q, and R. SRP. Please let me have your answer once you have it. Okay, Nicole, do you have an answer? What's the answer, Nicole?
I'm still solving.
Still solving. Okay. It should be about 1.5 minutes per question. Jiaming, any answer for question 1?
Is it C?
No. But let's try to see where is the mistake, okay? Switching U equal to Q plus W. Okay, that's for SQR. Okay, you look at SQR, they were saying that the work done is 3. So therefore I put out 3 here. And then they say the heat transfer or released by the gas is 8. So what should I put down here? The Q?
Negative.
Negative 8, because heat is given out, huh? Okay. So what is the delta U?
5.
Minus 5. Okay, good. Now let's go over to SQR, which is what the question is more concerned about. Okay. So I use the first law again. All right. So what can you tell me about the work done? What did they say?
It's 2 joules.
2. All right, and you hold on. Nicole, back to you. So we all know that SQR, the work done is 2, meaning that for fun, if you want to know, means this whole area is 2. Okay. So they want me to find the Q. I put a box here. What do I need? Delta U. What's delta U for SQR?
Negative. Wait.
Say again. What's delta U?
0. Wait. No, wait.
Can you see my cursor move? Is the cursor smooth or not, Nicole? When it's moving, is it smooth?
Yeah.
Smooth all. Okay, then what is the hint I'm trying to give you? What's delta U? I think, Nico, you're very used to answer and not hint. Okay, let me give you an answer again. Do you think the delta U from S to P, right, will be the same as the delta U from S to P? Stupid question. Do you think the delta U from S to P, is it the same as delta U from S to P?
Oh.
Yes or no?
Yes.
Yes, of course. Same initial temperature, same final temperature, of course it's the same, right? So -5. All right, and therefore the answer here will be? Nicole?
B, what, 7?
Yeah, okay. All right. All right. And, okay, let's try in integrity. Okay, just assume that you all don't use, look at the answer just now. Once you got answer for question 2, submit answer for question 2. So what equation will you use to solve this question? Think about it. Question 2. I see some of you got answer. Yeah, Atia got answer. Vishnu, Mesh got answer as well. Okay, good. Felicia, go on. Amruta. Amruta, can I ask you? Okay, what equation you use? Amruta.
I equated 3/2 PV with half
You
MC.
say again louder.
I equated 3/2 PV with half MC squared. So like
Is there such an equation? Half mv squared is 3/2 PV. Is there such an equation? From where?
no, but like then I just shortcut, I guess.
Oh, you think your shortcut will work? Should not do that. Okay, you should refer to your mind map. 3/2 PV is for total KE, not average KE. We spent a lot of time talking about average and total. Okay? Let me see. Felicia, what equation you use? Felicia, where are you?
Hello.
Yes. What's the equation you use?
P equals to 1/3 density V RMS square.
Okay. All right, good. Next time you just say V, I know it's RMS. It's okay. All right. So you are therefore looking at this one, and I agree with you because they ask for speed and they give you about pressure. So Amruta, look at how we decide what weapon to use. Okay, it cannot be random. Okay. Otherwise, sometimes you can do, and sometimes for the same question you cannot do. All right, because if you are random, okay, you should always look at the question. So you think this is better, lah? Okay. So I see that pressure is different, and I will highlight this. And what else is the variable, Felicia? What else is variable? The speed, is it?
The volume.
And the volume. Oh, so it's hidden inside density. So what should we do with density? Should we expose it?
Yeah.
And then what should we write down?
M over V.
Big M over V. Am I right? Big M over big V. Big V. So therefore, is mass the same?
Yeah.
The volume, not the same. To highlight. Is that right? So students, are you all able to use method comparison? Okay. So some of you, if you are not clear, let me show you that Felicia show you how to use method comparison. Okay, can I have the ratio for the first bracket here? The first one.
Will be
P what over P what?
P2 over P1.
Up to you, actually up to you. P1 or P2, P2 or P1. Then the next one here, what's this? Volume, right?
Yeah.
Volume, what should be on top?
V1.
1 on top, V2 below, okay? And then the speed, how do we differentiate volume and speed? Okay, the speed, the velocity, what should be on top?
2.
2, okay. Okay, Ken, pressure, trouble you, I want you to give me the pressure, P2 or P1, the ratio will be what?
1.25.
Perfect. Because you increase by 1.5%, okay. Look at how what Felicia is doing is called the method of comparison using the ratio method, okay. Okay, you have learned another method, I know. That method is not good. Okay, this one is very fast. Okay, Felicia, about the volume, V1 over V2. Maybe give me V2 over V1 first, easier. V2 over V1 is how much?
0.75.
Very good. See, your maths is very good, 0.75, because you drop by 25, so V2 over V1 is 0.75. Then this one will be what? 1 over 0.75. Okay? And you have to find the speed of the molecule, is it? The ratio? So go on and make it the answer. What's the answer?
0.97.
Perfect. All right. $1 for you. Okay. Nice. Can we all go on to question 3? If you had an answer, please submit in private chat over here. So, answer for question 3. Why is it that the temperature of the air in the basketball increase? Why? So what are we going to use? Okay, let me choose. Can I ask Sarifa? Sarifa, test your mic.
Hi, sir.
Sarifa, your answer is D. But can I ask you why A is wrong?
Because wait, where is it?
Where is A? Here. A. Why is it that I cannot say when you pump more air into the basketball, the air molecule collide more frequency, the FOC increase, and that causes the temperature to increase? Why can't I say that?
Because the temperature should increase first for the molecules to collide more frequently.
If I look at the mind map, I will disagree with you because the pressure depends on two things, the frequency of collision and the speed. I do agree with you partially. If the temperature increase, the speed will be faster, and the speed is faster will cause the pressure to increase. I do agree with you partially. But I disagree with you when you say that the pressure increase must be due to the temperature. I disagree with you because the pressure actually can go up if you have a higher frequency of collision. And I can understand that, Sharifa, if you pump more air molecule in the basketball, do you think that the FOC will increase? Hello? Okay. Never mind. I will say what you want to ask. So you are thinking about whether if I pump more air molecule into the basketball, whether the pressure will increase or not. I guess that when I have more molecule in the same volume, then of course there will be higher FOC, and higher FOC will cause the pressure to go up. So therefore, for this question, the air molecule collide more frequently. That's right. It means that there is higher FOC. FOC increase, and that is the reason why pressure increase. But what they want is why temperature. They want why temperature increase. So that's why I'm not saying that this statement is wrong. This statement is correct, but that is an explanation for why pressure is higher. But the question here is why temperature is higher. So if I change the question, if I ask you what's the reason why pressure increase, then you will say, or because more molecule in the basketball, when you pump the air into the basketball, and therefore there will be higher frequency of collision and pressure of the basketball will increase. Okay, understand? So A is actually okay. Now I'll look at option D. All right, Joanne. Option D, change in U equal to Q plus W. Okay, then let me ask you for this case, do you think that there's any Q, any heat transfer when I pump air into the basketball? Any heat transfer?
No.
No, because they say insulated, so therefore Q is 0. I put out 0, okay? Now, do understand that when you pump air in the basketball, the volume is constant. It's constant. We assume it to be constant. Most people do not know. Okay, again, this will not be taught in school. And in fact, in the A-level, they ask a lot of questions like this. So for example, in the recent A-level question, they pump air in the tire. So when they pump air in the tire, it's actually an isovolumetric process. Joanne, do you know why? Why when you pump air in the tire, when you pump air in the basketball, right? We assume that the volume will be the same.
Cause the shapes is the same.
Yeah, because the shape is the same. I mean, I do not know whether you all know. You all went to a tire shop before or not? I don't think so lah. But you know, the tire shop, they will display their different all the tire, right? They display on the on the shelf, right? So all this tire are actually no air one. It's very light one. You really carry it, it's very, very light. But they maintain the shape. Yeah, I do agree when you pump air in the tire, the volume will change a bit. But this increase in volume, right, is considered by A-level as negligible. But if you pump air into, Joanne, can you give that an example? You pump air into something, what thing, whereby you cannot ignore the change in volume? What would that be?
Beach ball. Balloon.
Balloon then you cannot ignore. But let's say tire, basketball, and all this, right? We assume it to be isovolumetric. So since the isovolumetric, Joanna, then would the work done on the basketball be 0 plus or minus?
0.
0, right? So initially you said 0, but that is wrong. Why? Because there are two ways to do work, two different ways. I have not teach you this in the additional lesson. I want to talk about it now. There are two ways to do work done, right? Two ways. Method 1, method 2. Let me show you the two ways. The first way is you compress the gas. You compress the gas. So that's the first way, you compress. Obviously, I'm not doing work by compressing the gas. Obviously. Because the volume of the basketball is assumed to be the same. The second way to do work, right, is what you have not learned in your school yet. Have not learned. First time. So please don't say you don't understand because you have not learned it yet. All right. First time we're talking about it is whereby you pump air, you add in more air molecule. I want you to consider this. Imagine that you have a classroom, and of course inside the classroom there are people, there are students in the classroom. So PMC classroom. Then PMC is being affected by COVID. Business is very bad. So they seem push people in. So we force people into the classroom because business is very bad. We force. So we actually push air, but the volume of the classroom is still the same. All right, but I just push air molecule in the classroom because they don't want to go in. So I just push them in and pump air. So actually, do I do work or not? You answer honestly. Actually, I do work. I have to push you in, But this time, the work done is not to compress the gas. It's not to make the volume smaller. The volume of the classroom is still the same, but I really push people in, force them in, they don't want to go in. So this is another way of doing work. So this is called, when you pump air, it's also considered as work done. All right? Now, in other words, if you look over here, see this? This change in U, right, is 3/2 NKT. I do want you to take note about these two things. All along, right, we always assume that the number of molecules is the same. So therefore, if the energy increase, right, confirm must be temperature go up, must be. But I want to let you know that we always assume that the number of molecules is the same. But when you pump air into the basketball, right, please note that this number of molecule, right, confirm will increase. Okay, so therefore your internal energy, I don't talk about temperature. Obviously today in this question, right, the temperature is increasing. I can see that. Okay, today I can tell you that both the temperature and the number of molecule increase. So that's why the internal energy of the system increase a lot. Why a lot? Because not only the temperature go up, but the number of molecule also go up. So the NKT increase a lot, not a bit, but a lot. Okay, the best way to increase internal energy of the system, right, is actually to just pump air into it. Double effect. All right. So coming back to here. So there is actually a work done because you pump air. So what is done on the air? All right, and there is no Q because you know that it's insulated, and internal energy actually increase. The internal energy increase for by the way, as I mentioned, two reasons. Number of molecule increase, temperature also increase. So that could be the reason. All right. Every time you do work on someone, either you compress the gas, right, or you pump air into the classroom, right. Either way, right, method 1 and method 2, right, you confirm the molecule inside the classroom move faster, one, definitely. I give an example. You compress the piston. This was the A-level H1 question. They asked why when you compress the gas, the temperature will increase using kinetic model. So you have to tell them, because when I compress the gas, right, the piston will pass some of the Ke to the molecule. Then the molecule will gain Ke. And therefore the temperature will be higher since the average Ke will be higher. 2 marks for this kinetic model. So you look at this one. When I pump air, when I kick in student into the classroom, force them in. So when I pump air, I need to give them velocity, force them in. This molecule have high velocity, you know. So when they go in, right, they will also pass a velocity to their friends. Or even if they don't pass to their friend, on average, right, the average Ke, right, on average will be higher one. So when either you compress the gas or you pump air, right, normally, right, the temperature will increase. Normally, why? But what if you give up heat to the surrounding at the same time? That is a different story already. Then I want to see who win already. If I give you energy 10 joules, you give out 12 joules to the surrounding. Then of course overall temperature should drop, right? Because your average heat will still be lower. You get what I mean? So it's actually a lot of things happening. But whether my temperature go up or down, right? Whether my internal energy go up or down, right? It all depends on the net effect of Q and W. Okay. All right. So that is question 3. Let's go over to question 4. Temperature per unit time. So the first part is that the temperature will drop. Is it? Temperature drop. Then after that, it undergo freezing from water to ice, or you can say freeze. So there are 2 processes over here. And they want me to compare the LF versus the specific heat capacity. This one will be in the mind map, which is Q to the MC theta, obviously. Go to the mind map. Your mind map should be at the side, so that you can just see whether your mind map is okay or not, good or not. You must stress test your mind map. Okay? It's here. So we tell you, okay, you are asked to replace the Q with PT, right? For this question, you don't need to care about the heat loss of the surrounding. Why? Because you are looking at how the ice, how the water is losing heat to the surrounding. So basically this Q, right, is actually the heat loss to the surrounding really. The temperature drop. But you replace it with PT. This is the P is the amount of energy lost to the surrounding every second per unit time. Why do you replace with PT? Because you see that they want temperature over time, right? So you move the power and the time you move over here. And you will get what you want. You want the temperature per unit time. No, you have it, which is 3. 3 over 60, sorry, 3 over 60. Then after that, you undergo freezing. Go on and if you're faster than me, you can go ahead, no problem. And then we go about freezing. Then the heat loss will be, of course, the MLH. Again, you got PT. So note that the power is always the one that is the same. Power is the same. The amount of heat loss every second, right, will be the same. I repeat, do you know that many students do not know the difference between P and Q? Q may not be the same. Q may not be the same. It may not necessarily be the same. But the power is always the same. For example, I use a heater to heat you up. The power is always the same. But however, the time duration may be different. So Q can be different. Our power is the same. You need to know that. Some may not know. So therefore, if you do not know that, I write down here. This one can be different. How much heat I lose to the surrounding, right, is always, every second is always the same. And with that, you have two equations. Equation 1, equation 2. All right, so why? Can I ask you for this question? I got two equations, and I realized that the power is the same, which is perfect. And the time over here, can I have the time over here for freezing to occur?
Sorry, what?
What's the time over here for freezing to occur? The time.
15.
Okay, 15. Choose the second now. Okay. So what should I do to the simultaneous equation? What should I do? I want to find this ratio. Red color, do you have a blue color, or blue color, do you have a red color?
Yeah.
Red color, do you have blue color?
Red divided by blue.
Okay. So, okay, which means that my answer will be left hand side. Power get cancelled away. I left with this. That's the left hand side. Right hand side, I left with this. Okay, good. I see that some of you got the answer as well. And therefore, what you want to find? You want to find the ratio of this. What's the answer, Subai?
A.
Oh, answer is A. Our answer should be A. Can I check? Answer is A. Any question? I don't see a lot of answer for question 4. Is it because you all find question 4 too difficult? Let me know if there's any question, any thing that you want me to explain. If you have no question, you have a question, you can put in the private chat, no problem. I will answer the question without addressing you, no problem. If you have any issue why you cannot get the answer, right, you please look at the mind map and ask, you have the answer why you don't get the answer, because it's obviously this equation. Okay, NC delta T. All right, now let's go to the next question. Question 8. It's question 5. Once you got the answer, let me have it. Pressure given, volume given. I got a habit to always do it this way. I'll go PS over PY, right, equal to 1/4, equal to 4. This way of presenting is so much better for me. Later on, when I need to solve a question, right, you appreciate this ratio given to us. What is volume, not pressure? Temperature is constant. This one must involve concept 2. Let me have your answer for question 5. So Annabelle, what would be the equation that I should write down? First step.
PV equals nRT.
Perfect. You choose the correct equation from the mind map. That's nice. So I know there are two cylinders. Okay, I will not trouble you. I'll write down for you. Okay, the pressure, then the volume is 1.5 V. That's for X, and then the number of mole of X and R, and the temperature is the same, so equation 1. And then the pressure will be different, it's P over 4. And then the volume for the cylinder Y will be just V. And then this is number of mole Y, and this R, and this is T. T is the same, all right? So this is two equation. Up to you. You may not write in the same format. You all may write down as PSVX, PYVY. That is perfect. I actually prefer it. You write down a PSVX, PYVY. Okay? I just write down the two equations. That's for cylinder S and cylinder Y. That was what happened before I opened the tab before. So Annabelle, the moment I open the tab, what happened?
The volume and increase.
The number of mole, I think you're saying that the pressure will be the same. Am I right? The moment I open the tab, the pressure will no longer be different. Really, it will be the same. So the air molecule will move on, right? Can you guess? Can you guess? The air molecule move from S to Y or Y to X? Give me a guess.
X to Y.
S to Y, right? Because the pressure is actually higher in S, right? So they will move on. But can they say, you know, some of them will tell you that this is P, right? Then this is 1/4, right? So P and 1/4, right? Then when you open up, the pressure becomes the same, right? Then they will tell you that this is P, this is 1/4. What would their raw answer be? Do you know? They will say it will be what?
The divide by 2.
So it will be what? A, B, C, D. This is a common problem. In fact, a lot of teachers make the mistake in school. Okay? This was because one time HCI said a question. And that question, right, the pressure, right, happens to be what? The average of these two, which will be what? Annabelle? The average of these two will be what? 0.75, am I right? 3/4 lah, 3/4. 1/4 ma, 1/4, then this 1, right? So on average, it's 3/4 lah. So this is wrong. But there was once HCI said a question, and then the answer was like 3/4. Just nice, it's a coincidence. So then a lot of people think that, that means that the pressure, right? This is P over 4, right? And then on average, they find the average pressure. Cannot. Okay. Now, can you raise your hand? Which school teach you this thing called partial pressure? Not partial fraction. Partial pressure is in maths. Partial pressure. Anyone hear of that before? Partial pressure. If you don't, you all know, never hear of partial pressure before, right? Anyone? I'm looking at the screen. No one. If no one learned partial pressure before, good. They cannot teach you that method. That method is actually not in A-level syllabus. You need to solve this question using what? Using PV-nRT. You don't need any other formula. So therefore, Annabelle, so for this question, right, when we open the tab, both of them got the same pressure. Immediately, you look at S and Y as a what? As a system. Am I right? So therefore, I give you PV-nRT again, all right? And then the pressure, of course, is the same in the system. And the volume will be, what's the volume? You add up together, the volume?
4.5.
1.5 and V, and 1, right? 2.5, is it?
Yeah, 2.5.
2.5, so it will be 2.5 V. That will be the volume. 2.5, you add up together. Then the number of mole will be what? NS plus NY. Is that right?
Yeah.
Okay, so therefore NS and NY. So to save time, right, I put out like this, it'll be 1.5 PV over RT. That will be NS. And then I'm going to write down NY for you. NY will be 1/4.25 PV over RT. Okay, so we have solved this question in the additional lesson as well. You can see how the RT get cancelled away. All right, and then you will be able to get the answer. So just take note that I think we should give this a name, you know. So Annabelle, we should call this a P1, because it's a new pressure. This pressure will not be the same as the old pressure of S, right? So what should we call this thing? You decide.
What?
John, Peter, what name? P2 can, P2, I call it P2 can. So we're going to find P2, okay, make P2 the subject, okay? All right, perfect, P2, the final pressure, final pressure, P2. So of you, you will get, RT will get cancelled away. you express P2, okay, in terms of the original pressure, which is 0.70 P. And then just to double confirm, do you use somewhat the same method?
Yeah.
Okay, perfect. You know, some of them, right, they will not be able to get the answer. I'll tell you why, okay? Some of them, right, when they get the equation here, you know what they do? They divide. They divide 1/2. This time, right, you don't need to divide. This time, 99% you divide, I agree with you. This time, right, I want you to total up NS and NY. So I need you all to make NS and NY the subject and add together to throw inside. Okay, and this seems to be faster. You may not like it initially, because got so many things here, but you trust me, trust me. The RT, right, will get cancelled away. Okay, because they say there's no change in temperature. When I open the tab, right, there's no change in temperature. The temperature remains the same. See here? Okay, good. Am I at question 6? Okay, can the rest go over to question 6 if you are done? I stay on the screen for just a few more seconds. Quick, time is up. Question 6, oh, so many. Cannot. Then I do for you. Okay. Now density, rho, wrong. This is pressure given to me, and density. And then I ask to find the root mean square speed. I show you how I solve it as a student, okay? So in my mind, right, my mind got the mind map. So I will scan through the mind map. I say it must be concept 2. And I look for the equation, pressure, density, and speed. I look for it. Oh, it's here. I remember it's here. See? Okay, when I give you equation P is 1/3 rho V squared. Then your school lecture notes give you equation P is 1/3 NM over V squared. Which one you remember? You must remember the one I give you. All right. You don't remember the other one. Okay. I remember the simple one. If you need mass and volume, I can break down, no problem. So now I'm going to move forward and say must be pressure 1/3 rho V squared. You're asked to find the root mean square speed. Density is 1.178 and the pressure is 150,000. And therefore, I will get the answer for the root mean square speed. Answer will be 8, question 6. Then we look at question 7 now, okay? This one easy, right? Okay, question 7. I see they give me pressure, give me volume. They ask me to find the ratio of the speed. Speed, root mean square speed. Then they give me that the two graphs are of different temperature, T1, T2. Now, first thing first, do you know that, look at the red color one, look here, everyone. You will see that this temperature represents T2, see T2. It means that this graph here is an isothermal process. You don't believe me, right? If I choose two random points on the graph, right, the product of P and V, right, will be the same. See, PV will be this one, right, PV. So P plus V, this area. This one, PV, confirm the same, see, confirm. Isothermal, temperature the same, PV must be the same. You choose center, also can. 2 times 2, 4. Confirm the area will be 4, the PV will be the same, all right? So you don't need to draw in, obviously. I just want to show you what I say in the additional lesson is correct, okay? So it's this one represents T2. Then this one represents T1. Obviously, T1 will be below T2, right? Why? Because you have lower temperature than T2. One look I can see you have lower temperature, okay? They asked me to find the speed. So one look must be average KE equation 3/2 KT. That is for my mind map. So I'm all constantly looking at my mind map. Sometimes I may not flip over to the secrets and close, but you must trust me that in my mind, right? My mind is switching from one book to the other book. I'm looking here in my mind. So I'm looking at the speed and the temperature to be the variable. All right. So in order not to waste time, I quickly half mv squared. This is RMS. My way of solving is better, is faster. Immediately it will be square root of what? T2 over T1. This one will be V2 over V1. Like this. Look at this. Am I right? Because I only focus on the variable, the speed and the temperature. Look at this. This is called the method of comparison, because I only teach that in J1. So if you are not here last year, look at this method. You study the variable and then you just put it in ratio form. Now wait, hold on. How do I find T2, T1? I have a problem. So therefore, Brandon, How do I know T2 and T1? How do I know? I need to know the ratio of T2 over T1. What should I do?
Square the V2 over V1 ratio.
Say again, I square the V2 over V1. Okay, first of all, I need to tell you the story because you don't know the story yet. I want to find V2 over V1, and therefore I need to find T2 over T1. Any idea how to get T2 over T1? Once I have this one, I will get an answer already.
Use the ideal equation.
Use the ideal equation of state. Very good. Okay, can I have the equation? Can you just write it down and put it aside?
PV equals nRT.
PV nRT. Are you implying that I should look at the ratio of PV if I want to find the ratio of temperature? Is that what you're implying? Okay,
Yeah.
all right, no problem. This is for 2, and then this is for 1, right?
Yeah.
Okay, so you decide. You decide, right, Brandon? You tell me which one you want to use, okay? Because any point is possible, right? For this graph here, which one you want to use? Which point? What's the PV?
The one where V equals to 1.
Okay, so what would be PV?
10 to the power 5.
Don't care.
Sorry,
Ratio,
sorry.
ratio.
Oh,
Don't
four,
care.
four,
Don't care.
four,
Or you choose any point also 4 anyway.
Yeah.
Okay. And then this is not too easy for you. Cannot. I want to ask you the blue color one. PV for graph 1. Which one you use? Which one?
1.
Oh yeah, nice. Will anyone try to estimate where is this point? Cannot, obviously. You will use any point. You definitely use this one, right? It's easy. One is 1, no? 1. So what's the answer? Square root 4. Answer will be 2. Answer will be C. All right, Isaac. Last question. This question asks about pressure against temperature. Can I have the equation for pressure against temperature? What should I use?
PV equals nRT.
Perfect. What should I do after that? What should I do after this?
Find the ratio.
I mean, what should I do after this? After writing the equation, right? Second step, you must tell me, because of the graph, right? The y-axis is pressure, then you make pressure the subject. I'm sure you'll do it, but maybe you think it's not necessary to say it, but I want them to know. That's what we do. We are not stopping. When we do question, there's no time lag. All right. So it's this nRT. So pressure is here already. Okay, against what? Against temperature. See? All right. So first of all, by the way, the graph must be what? Linear. So the graph is linear. What should be the gradient of the graph?
nR over V.
nR over V. nR over V, yeah. The gradient. So therefore, this question asks you, if I were to have a greater volume, greater volume, Vs is bigger. Greater volume means that the gradient will be higher or lower? Gradient.
Lower.
Lower. Then what's the answer? Gradient of S will be lower. I write down for you. You're saying that gradient of S will be lower because the gradient is nR over V, right? So let's step up. So I saw it. Did you see it? Must be A or D. Which one?
Is it D?
Is it D? Can you tell them why D? Because a lot of them will say A. Why? Tell them why.
Because it's not in Kelvin.
The temperature is in degrees Celsius, right? Yeah. Okay. By right, if I were to draw the graph of pressure against temperature, if this is in Kelvin, right, then this one will be 0 Kelvin. Am I right? Okay. Okay or not? Okay. Correct. 0 Kelvin. By right, you should cut here, at 0 Kelvin. But this 0 Kelvin, they change to degrees Celsius. So my 0 Kelvin, right, becomes what? How many degrees Celsius? Wait, will the number get bigger or smaller? The number. Kelvin change to degrees Celsius. Number get bigger or smaller?
Smaller.
Smaller, degrees Celsius. Because become how many degrees Celsius?
-273.15.
-273.15. All right. Sure. So basically, when I hit the S-axis, right, the temperature is -273.15. 15 degrees Celsius. True or not? Okay. I think we are more interested in where will the graph touch the x-axis. The graph will touch the x-axis at 0 Kelvin. So if you draw the scale to be Kelvin, then original. But if it's in degrees Celsius, then it will be minus 273. So you have a negative x-intercept. Okay. Different people solve it differently. Some of you will want to solve it this way. What is the y-intercept? Is the y-intercept positive or is it 0? Which one is easier? I tried it before. Find x-intercept easier. Because the x-intercept is the temperature, right? So the x-intercept must be 0 Kelvin or minus 273.15. You choose which one you want. Okay, better. Looking at y-intercept harder. All right, so that's it. We have completed the quiz. Wow. I'm late. I got G1 coming soon. All right. I want everyone to just send me a chat message in the public chat. Okay, and say bye-bye to me. I will see you coming Wednesday. All right. So this coming Wednesday, I'll be going through work energy power, circular motion, and gravitation. That will be a big chunk of a JC1 syllabus. Especially gravitation is so important. Okay, you remember the satellite question, the escape speed, and so on. All right, that will be my third lesson. Okay, now once you have submit your attendance in the chat group, you can leave the meeting. Okay, so sorry that today I cannot answer questions because I overrun, and my J1 is going to start very soon. Okay, but if you have any question, just either you WhatsApp me or WhatsApp HQ, or you can see me on Wednesday after my additional lesson. Okay, bye bye. Alright, just make sure that all of you have marked your attendance. Have you marked your attendance already? Okay,